Welcome to my 8th graders. This is Mr. Roundy coming at you, not live, but in video recording. So, today we have got a lesson on comparing functions. Now, in our last lesson, we were learning about linear functions, which are basically just linear equations like we learned in chapter 3. Chapter 3, we went over good old y equals mx plus b, where m was our slope of our line and b was the y-intercept. And in our last lesson, all we did was basically figure out that, hey, we can still graph these. These are functions as well. We just sometimes write them a little differently and we say f of x equals mx plus b. So we're still working with our linear equations. Now we're calling them functions because we've got a domain and we've got a range. Okay, so in this particular lesson, we're going to be comparing different functions that are written in different forms. So in past lessons, we've mentioned that we can show a function in several different ways. We've shown them as tables, where we've had the domain on one side, we've had the rule in the middle, and then we've had the range on the outside of the table, and we've had our function table. Okay, so that's one of the ways that we can write a function. Another way we've written functions is to use an equation, such as y equals mx or y equals mx plus b, or in some cases we've used this funky symbol f of x equals mx plus b. Okay, so an equation is another way that we can write a function. The final way that we've represented a function is with a graph, where we graph the domain and range. Remember, the domain is the x value and the range is the y value. So all we've done is graph the different points. Like in the last lesson, we were doing linear functions. So we were doing functions that made a straight line. And if the dots had to be separated because they could only be whole numbers, we called that a discrete function. And if the domain and range, or the domain, I should say, could be fractions or decimals, then we could use a line to represent it because every teeny tiny little point along that line could be one of our domains. And we called that a continuous function. Continuous had a line, discrete just used dots because it could only be whole numbers for the domain. So those are three ways that we describe functions. There's actually a fourth way that a function can be written, and that is just by using words. We can use words to describe or write a function. So we end up with a list of 4 ways. We've got words, a graph, an equation, or a table. So today we're going to be comparing functions that have been written or represented in different ways. Maybe a graph compared to an equation or a table compared to the word version. We're going to be comparing these functions. Let's take a look at our first problem that we want to work on today. And our problem says a certain car has a gas mileage of 22 miles per gallon. The gas mileage of a certain sport utility vehicle is represented by the function shown. Compare their gas mileage. So what we have here is 2 functions. We have the first car that is actually being shown as 22 miles per gallon. So they've used words to represent this function, per gallon. And the second one is represented with the graph that you see. And it's got points at 119, 238, and 476. Now this problem says that we need to compare their gas mileage. Well, for the first function, that's pretty easy. They've given us word form and they've told us what its gas mileage is. They said the gas mileage is 22 miles per gallon. Now what we need to do is figure out the gas mileage on the second car, or the sport utility vehicle that's represented with the graph. If you take a look at the graph shows that at 119, and then our next point is at 238. Well, the X value is the gallons that are used, and the Y value is the miles that are driven. So in 1 gallon, we go, or I should say, with 1 gallon, we go 19 miles. With 2 gallons, we go 38 miles. To find out the miles per gallon, I can look at any one of these points and see what is happening. So my change in the miles is 19. The change in the gallons is 1. So I've got 19 miles per gallon. And so that is my gas mileage, 19 miles per gallon. So I've got 19 miles per gallon compared to 22 miles per gallon. So my first car would have the greater or better gas mileage. Let's do another problem that requires us to compare functions. So here's our second problem. A bowling alley offers different birthday party packages. Package A is represented by the function C equals 7p plus 5. So I'm going to write that down. C equals 7p plus 5. So they've given me my first function in equation form. It goes on and says where C is the total cost and P is the number of people. Okay, so cost, people. Package B is represented by the table below. So you're seeing the table right there. And on our table, I'm going to write down some of the things it tells me. It says 1, 9, 2, 18, 3, 27, and 4, 36. And the first thing it wants us to do with these two functions, the table and the equation, is A, compare the functions by comparing their y-intercepts and rates of change. Okay, so it wants us to compare their y-intercepts. Well, I'm going to start with my equation. My equation should be pretty easy to find my y-intercept because it's given me a y equals mx plus b format. They've just used different variables. It's still y, but they used c, equals m, which is 7, times x, but they used p instead, plus b, and their b is 5. So my y-intercept is 5. Now it's a little harder to find the y-intercept on my table. The thing I have to remember is the y-intercept on a graph is the place where we cross the y-axis. So if I have a line and it crosses the y-axis, I'm looking for this point where it is right here on the y-axis. Now, ordered pairwise or coordinate-wise, this would be at the location 0 and something. The x-coordinate is always going to be 0 at the y-axis. So if I have a table, what I'm going to be doing is trying to figure out what the value is for the range when the domain is 0, because remember, domain is x. So if I know what the domain is 0 and I can figure out what the range is, then I know what things are going to be. So at 0, well, let's see. Here I was going from 1 to 2, 2 to 3. So each time I was increasing by 9. So that means if I want to go up here to where 0 was, I would decrease by 9, and that would get me 0 as well. So my y-intercept on my table is going to be 0. So my first function for the first package of bowling is going to be a y-intercept of 5, and my second bowling package, it's going to be a y-intercept of 0. The second thing it wanted us to compare was the rate of change. Now the rate of change is actually pretty easy to find on any equation. An equation, the rate of change is just going to be my slope. Okay, I'm increasing by 7 going over 1. So that would be a rate of change of 7. On a table, it's fairly easy to find my rate of change because I would look at how much I'm changing. From here to here, I've got a change of 1, and from here to here, I've got a change of 9. So that means I've got a 9 over 1 rate of change or just a rate of change of 9, just like my slope. So on my first function, my rate of change is 7. On my second function, my rate of change is 9. Okay, so I've rewritten my table and my equation, gotten rid of all our work. Now let's look at part B. Part B says, how much more will package B cost than package A if there are 12 people at the birthday party? So what I'm going to do to find out how much more is I've got to find out how much each one costs when there's 12 people. On the first problem, that's fairly easy. P stands for the people, so I'm just going to replace P with the number 12. And 7 times 12 plus 5. 7 times 12 is 84, plus 5 would get me a C of 89. Now on my next one, I can see that I have got increasing by 9 each time. So let's see. If I go to 12, basically this is 1 times 9, 2 times 9, 3 times 9, 4 times 9. So 12 times 9 would get me 108. So on my second one, it's 108 would be my cost. Now it wants to know the difference or how much more will package B cost than package A. So to find out how much more, all I've got to do is subtract the cost of A from the cost of B. And that's going to get me $19. So the difference between package A and package B is $19. That's the answer for B. How about we do another comparison? In our third problem here, we have the number of new movies a store receives can be represented by the function m equals 7w plus 2. M equals 7w plus 2. Remember, this is just y equals mx plus b. So we've got a slope, we've got a y-intercept. Now we've written this function in equation format. It says where m represents the movies and w represents the number of weeks. The number of games the same store receives is shown in the table. So we've got our table and we says week and number of games. And we've got 1 and 3 and 2 and 6 and 3 and 9. And it asks us, compare the functions y-intercepts and rates of change. Okay, let's figure these out. Y-intercept on the first one is easy. Y-intercept is 2. Now, let's figure out our y-intercept on the second one. Remember, y-intercept is where the x is going to be 0, or the domain will be 0. So I could just write in a 0 right here. And I noticed that these ones were going up plus 3 each time. So if I subtract 3, that should take me back to the one where 0 would be. And this one has a 0 and 0, so the y-intercept is our 0. Ooh, running out of room here. Okay, so 0 is our y-intercept on the second function. The first function, our y-intercept is 2. Now it wants us to compare the rate of change. The rate of change on this first one is 7. We can find that by looking at the slope. The second one has a rate of change, if we compare the games to the weeks, of 3 to 1, or has a rate of change of 3. So our first one has a rate of change of 7, second one has a rate of change of 3. Let's answer the second part of this question now. I've rewritten our problem and cleared away all our work, and we're going to now answer the second part of our question. It says, how many new movies and games will the store have in week 6? So let's figure out how many new movies it's going to have in week 6. To do that, all I've got to do is replace the week with the number 6 because it said 6 weeks. 7 times 6 is 42 plus 2 gets me movies equal 44 in 6 weeks. Now for the games, we're going to look, we say, okay, at week 1 we had 3, at week 2 we had 6, at 3 we had 9. Looks like we're just multiplying by 3 each time. So at week 6, if I multiply by 3, that means we're going to have 18 games. So the games is going to be at 18. And there is our answer, 44 movies and 18 games. That's all, class. Hope you had a good one. We'll see you next time.